Solving cubic equations. In this example, I'm asked to solve for x, and I have the cubic equation x cubed minus x squared plus x minus 1 equals to 0. So because it's a cubic equation, that means an equation of degree 3, or the largest exponent will be cubed. I know that this equation will give me 3 solutions. So to find the solutions, we need to factorize this equation. And the method I'm going to use is grouping. So I pair off, or I group the first two terms and I group the next two terms. And in each group, I identify a highest common factor. So in the first set of terms, my highest common factor is x squared, and x cubed divided by x squared is x. X squared divided by itself is negative 1. In the next two terms, it seems as if there is no highest common factor. So I'm going to take out 1 as a highest common factor, and then I get x minus 1 equals to 0. And the reason why I've done this is because when I'm doing grouping, my repeated factor must be the same. So I take out this as a highest common factor, so I have x minus 1. And if I divide the first term by x minus 1, I have x squared. And if I divide the next term by x minus 1, I have x squared plus 1, and that equals to 0. Now I have two factors whose product equals to 0. So I know that either one of these factors have to have a value of 0. So either x minus 1 will equal to 0, or x squared plus 1 must equal to 0. So I'm ready to solve for x now. I have x equals to 1 because I transfer 1 across the equals to sign, and then I change the sign, and negative 1 becomes positive 1. And in the next set, I am going to do the same. So I get x squared equals to negative 1. Now I need to solve for x, so I'm going to find x by square rooting the left-hand side and the right-hand side of this equation, and reminding myself that the answer must be plus or minus the square root of that value. So I get x equals to plus or minus, and the square root of negative 1 we now know is I. So this cubic equation has got 3 solutions. The first one is x equals to 1. The second one is x equals to positive I. And the third one, x equals to negative I. We have a real solution, and we have 2 complex solutions. And you note that the complex solutions are complex conjugates of one another.